Right. So our next speaker probably needs very little introduction. Are we bringing him onto the stage? Is it happening? It's happening. So yeah, he's probably the most prolific live streamer in the cloud native ecosystem. His media empire includes Raw Code Live, Slash Looks Good to Me on Cloud Native TV, and of course, Klustered. It's David Flanagan. How are you, buddy?
I'm doing really well. It's nice to be here. How are you?
I'm good. I'm good. So have you recently become have you got a little one, a new little one?
You're so close. So I have a 3-year-old and I have a minus 2-day old. So someone due within the next couple of days.
Oh, I knew
so
it was. I knew it was either coming or just happened. So
yeah, it's close. I mean, I may have to just leave any minute right now, to be fair, but hopefully that won't happen.
Let's talk out the way quick then. So your reputation clearly precedes you because Dan Papandrea turned up from New York in the middle of the night last night.
A day early, I know. What's that all about?
To troll you, and he's not here today, so he missed his opportunity.
Oh, I'm sure he's got some tweets scheduled, and I know Dan.
Yeah, almost certainly. Right, I will pass you the floor and have at it.
All right, let me see if I can work this thing then. So I'm going to click the share sound button because I am hoping we're going to be able to play a little bit of a video. Oh, thanks, Tim. I believe you can. And this talk is called What I Learned, Fixing 50 Broken Kubernetes Clusters. So this is a little bit of a knowledge share from my series Klustered, which I run on my rawcode.live YouTube channel, where we break clusters and then try to fix them live in front of an audience. Now, a little bit about me. I'm a senior developer advocate focused on cloud native and Kubernetes, and I work for a company called Equinix Metal. I also am a CNCF ambassador and Influx Ace. I am the host of the official Kubernetes office hours, co-chair of Cloud Native TV, as well as host of LGTM, as Matt said. And my YouTube channel that I devote far, far too much time to is available at rawcode.live. Now, Klustered is really good fun. We are, I think, 25 to 28 episodes in right now, depending on if you count teams, solos, and the newcomer edition. And the general idea is really, really simple. I reach out to friends within the Kubernetes community. These are Kubernetes contributors and end users. And I give them a freshly baked Kubernetes cluster and tell them to break it whichever way they can. They don't give me or the other members of the Klustered episode any information on what has been broken. And we go live and we share our screen and we try to work through all of the broken bits, identifying symptoms and looking for cause and effect to see if we can get that cluster back online. And on paper, it's really simple. All you have to do is upgrade the clustered pod from image v1 to image v2. Of course, one of the things I've realized during the 20 plus episodes is that people are particularly mean, very, very mean. So I've got a little video to start. It's just a couple of minutes long, and I want to give you a taste of what Klustered is. So hopefully you can hear the sound. Hopefully it's going to play. Yeah, we still have no cluster DNS. kubedns has endpoints. Okay, that's after 8.
Yeah.
Let's see if Guy wants to jump in and give us a last bit of advice before we wrap this up. Are we close?
You've not looked at the configuration of core DNS. You've looked at the pods, but not how the pods are configured to run the DNS.
We have no DNS. Just keeps coming. All right. Did we miss something? Let's. I'm going to say cheat. I'm going to jump onto cluster 14 and grab the config map and see what's different.
What about?
Yeah, these are the exact same file. Yeah. So he told us to look in the core DNS config, and then there was nothing wrong with the core DNS config. That's just cruel. Saying there's a few pixels. If this is a white space error in the core DNS config, I will be mighty frustrated.
Mm. It might not be a white space error. Damn.
He's mocking us now because he said your jumping back and forward showed a slight difference. This number
Okay.
seems arbitrary. Oh, you son of
Yeah.
a bitch. I'm assuming there's like a weird bug, and I'm sure he's found it because he works at Skyscanner and they've got a level of scale that most people don't have. But something to do with this number going so high is maybe causing it to load an old config map in the pods or something. I don't really know. But the number being so high worries me. But we're now at the stage where I have to go and pick up my daughter. So
Yeah.
I'm just going to bring Guy in to tell us what wonderful magical
What we should
crap this is. Yeah. All right, Guy. Lay it on us.
So when you were jumping back and forth between the working config and the non-working config, if you look really hard at the C in front of it in the Kubernetes config,
Oh, you bastard.
The C?
yeah, it's not a
C.
C. No, it's a character which looks a lot like a C.
What?
So the Kubernetes plugin became authoritative for letter that looks like a C, luster.local.
All right. So that was particularly mean. That was a Unicode issue in the core DNS configuration. There we go. So that was the first time I ever changed the rules on Klustered, and Unicode changes are now banned. What I love about that clip and that episode specifically, I mean, excuse my language in it, of course, but Guy had me questioning primitives, like complete basics, like why was I questioning the resource version going above an i8 or an i16, right? And trying to like overflow back to older generations. Like, of course, that would just not happen because it's obviously going to be an i32 as a minimum. But you get in this position when you're debugging, and I think that's really important, is that debugging these things is really difficult. And it's going to challenge all sorts of assumptions, and you're going to make wild guesses that will be wildly inaccurate. But getting things wrong is normal. And if we look at Albert Einstein here, failure is success in progress. We have to learn. It's through all of these mistakes that we learn the things that we need to learn. So I'm going to take you on my path of failure from Klustered, all the assumptions that I made and the things that I got wrong and the things that I learned. So the first thing, and probably the most prolific attack surface that people use on Klustered to break these clusters is the Linux system itself. Now, this is just a really shorter video,
Free to just go,
just to
or what?
demonstrate what we see.
Get some notes, man.
Let's see. Permission denied.
Oh. Let's check.
Ed, you've hit your first snag. There we go.
Okay. Make it +X.
Yep. I need my autocomplete stuff. I'm lost.
You didn't install fish while you're here too?
I can type if you want.
Oh,
Okay.
Nice.
okay.
It's an interesting start.
Yeah. Do an ls-l-a on user bin change mod, or probably just bin change mod. Oh, bother! You don't even have tab completion? What is
No, I
this?
don't. It's killing me. But hey, we'll make it work.
If you don't, I think that's
Oh
probably
wait,
because
we
they've
can't
done something.
mod that.
Yeah,
Well,
exactly. So
yeah.
just look at the whole/bin. Is there anything which is executable at all?
Well, ls is
No.
obviously.
All right, so take a look at this screenshot. This is the Teams edition. This was Red Hat versus Talos Systems, and Jiffy and the Red Hat team and his other colleagues removed the executable permission from chmod. Not only that, all the files and binaries that we see in white here also had the executable permission removed. So that's change attributes, chmod, kubeadm, kubecontrol, OC, which they were using as an alias to kubecontrol, SCP, so they couldn't pull in other files, and even Perl. And what I love about that is that it's really, really simple, a mistake that we could all make easily, and not something that everyone is fully aware of how to fix. So kube control and kube admin was, you need those to be able to debug the cluster. Removing the chmod and change attributes was just plain cruel. And even removing the executable attribute from Perl allows you to actually execute syscalls on files really easily. That command is a lifesaver. You should keep a note of it. However, what we learned on that episode is you can actually use the dynamic linker directly to execute binaries on the machine that don't have the executable bit set. And in this case, we're using the dynamic linker to re-enable the executable bit on the chmod binary itself with the chmod binary. And I think that's a wonderful tip and a great debugging thing. Also, something I learned during Klustered is Linux file attributes. I'm familiar with the chmod, the 777, the 644s, etc. But there are extended attributes on all files. And in fact, you can make files immutable. And I can't remember if it was Dan Finneran or Jason DeTibris, but they both, or one of them at some point, made the etcd write-ahead log immutable, breaking etcd. So these things are really, really cool, but not if you don't know they exist. The next biggest attack surface we see on Klustered is networking. So beyond Linux, they always like to try and mess with the way the systems within the Kubernetes cluster communicate with one another. And what we've discovered with networking is that there is a life after IP tables. You may be familiar with EB and NF tables. Something I wasn't aware of until very recently on an episode of Klustered is there's a concept of traffic control, a TC command for manipulating the packets on the device through quality of service rules. And of course, we've got EBPF and XDP, which are being leveraged heavily by the Cilium project. Now, what I didn't know about IP tables before Klustered is that you can actually apply drop rules using the statistic module to apply a randomization effect to the drop packets, causing what appears to be intermittent errors at the IP tables level, particularly sneaky. Another common attack surface we've seen is people changing the DNS policy on the pods. There is a DNS policy in Kubernetes called default. It is by no means a default. It does not use cluster DNS whatsoever. And in fact, cluster first is the default DNS policy. So it looks like when you look at a pod spec and you see DNS policy default, you probably think that's all right. But that's a warning sign that you probably want to fix something. Something else we've seen is network policies with Cilium. Cilium can use standard Kubernetes network policies and apply those rules for you directly. But Cilium has extended that API with their own Cilium network policies as well, which add an extra layer of abstraction, obfuscation to what's actually happening within your network. Cilium also has cluster-wide network policies that will modify the traffic shaping across all the nodes in your cluster. All of these things are very tricky and delicate and need to be handled with care. There's some tips for working with networking. I'm not going to stand here and say everyone should adopt Cilium. Of course, you've got your own needs that have to be met, but Cilium is a wonderful CNI implementation, and it ships with something called Hubble. Hubble gives you a visualization and user interface into all of the network policies across your cluster and service communication, showing you in real time packets that are being dropped or accepted, allowing you to kind of trace all these requests through your system. It is a super power tool, and I encourage everyone to check it out. Even if you're not using the Hubble and Cilium, Cilium provides an editor for modifying and working with these network policies as well. You can go to editor.cilium.io, and you can actually start to build through a visual interface or dropping a YAML into the box to visualize the network policies that you need in your system. This is a really quick and fast way to bring in those network policies. And I've seen time and time again that teams are reluctant to do this because it's a dangerous and daunting task. Nobody wants to bring down their cluster networking. Now, next is etcd. This is the biggest, scariest one that we ever see. I don't think anyone who has ever appeared on Klustered has been happy when etcd is unhappy. Nobody is actually that familiar with debugging etcd itself, and nor should you be, right? But there are a few things that you need to be aware of. Number one is we've seen many people now on Klustered attack etcd by modifying the quota or filling disks or writing arbitrary junk data into etcd itself. All of these end up with an etcd alarm. Now, even when you fix the problem by clearing up the space, removing the junk keys, increasing the size of the resource quota, that alarm stays in place, even if you restart etcd and all sorts of things. It was only through trial and error and pain that we realized you actually need to alarm disarm for etcd to become healthy and happy once again. Another thing we've seen very recently, this was just last week on Klustered, is that Barco, a member of the Kubernetes office hours, decided to enable encryption very nicely on a clustered cluster. However, he only partially encrypted all of the secrets and config maps within the system. Oh dear. So what this meant is that we couldn't pull or query any default namespace config maps or secrets. There's a really cool trick to working with the encryption system in Kubernetes, and that is to add multiple keys and multiple providers. And in fact, the way that you turn on encryption is to enable the identity provider, which is the default unencrypted provider, add a new key, and then literally you get all the secrets and all namespaces as JSON and do a kube control replace to re-encrypt the values as they go in. The encryption in etcd and Kubernetes at rest is applied when modifying or writing to etcd. And the way to fix the partially encrypted problem is just to add both providers. So add a key and an identity. And in fact, the way that you do key rotation as well in a Kubernetes configuration is to add multiple keys and then remove the old key after you've done the get and replace. All right, so where next? That's a really good question, but there's something I want to address first. There are a lot of places that you can attack a Kubernetes cluster. And I've built this word map just to show roughly what's going on. But we've seen people attack the CRI, the CSI. We've seen people attack the controller managers, even to the extent of recompiling the controller manager and publishing their own image, or recompiling the kubelet and publishing their own image, making things immutable, applying policies via Kyverno, JS policy, OPA, etc. People get really, really creative. The surface that you need to know in order to be successful in running Kubernetes is ever expanding and dangerous. And this isn't really a talk about failures specifically. I don't know if you've been paying attention to the quotes as we move through, but all of this failure things where I'm talking about the next area we want to address is a quote that tells you that failure is just a part of the knowledge cycle. The way that we learn is by dealing with these problems. And I think that is crucial. So what I'm going to encourage everyone to do is to remove hero culture, right? We don't need hero developers. What we need is the confidence and the ability to say, I don't know within our teams, within our organization, and if you're bold enough to do it in public. I get in front of an audience every week with Klustered and spend most of my time going, I have no idea what I'm doing. And I think I'm pretty good at this. And we have a duty and an honor to set a precedence for new people entering this industry. The hero developer is no longer a thing. So my journey next is taking me towards EBPF. I have noticed through all of these Klustered episodes, the EBPF probably has the answer to every problem that we've ever dealt with. And I'm going to use one slide just to try and show you what I mean by this. So EBPF is really performant, has a bytecode compiled into the kernel that exposes tracing probes, allowing us to understand what is actually happening at the kernel level. There are some really great projects in this space for Kubernetes. Cilium, we've already covered. Falco by Sysdig is amazing for getting into the audit log and the events happening within the Kubernetes system. We have Inspector Gadget by the Convolt team and Pixie by Pixie Labs for completely autonomous, uninstrumented observability into your Kubernetes cluster. You should definitely check it out. Inspector Gadget exposes all of the snoops that I've listed here in a Kubernetes context. Exec Snoop is a BPF program that will tell you every time a new executable is run on a machine. IO Snoop, Open Snoop tell you when files are opened or being written to or being read from. And then there's all the TCP snoops as well, which are going to give you visibility into all the packets within your system. eBPF is a superpower, and it's what I'm really keen and excited to be learning next. If you want to learn more yourself, there's some links here. I'll publish a link to the slides on the Slack channel momentarily, but check out the BCC examples at github.com/iovisor/BCC. And what comes next? I'm not entirely sure yet, but I'm looking forward to failing a lot more. Thank you for your time.
Hi, David. Thank you. That was excellent. I do wonder how you put yourself through live fixing of Kubernetes just continuously. It looks like you have fun doing it.
It is a whole lot of fun. Once you get over the awkward bit, like, oh, I'm just going to be completely confused. I'm going to have no idea what I'm doing. But it's through collaboration and pairing. You know, I'm not doing it alone. I have a guest with me. We have teams. We talk about the symptoms. We try and understand the problems. And it's through those conversations that we actually are able to share so much knowledge with the broader Kubernetes community. So It can be painful at times, but it's one of the most rewarding things I've ever done.
Fantastic. Well, we're running slightly over, so I will say thank you very much. And then if there's any questions, if you're hanging out in the Slack for a bit, then folks can hopefully post some questions into Slack and you can take a look. So we are taking a quick break. Time for folks to grab coffees or water. Get yourselves ready for our next session. We'll be back in around about 5 minutes time. Thanks, everybody.